customize large language models. So this is an overarching picture. So far we have been talking about how we build the model with the training data and how to train the model to perform better. Actually, all of those discussions is in the red box. So we have different formats of data and we pre-train the model, and this model is called pre-trained model or foundation model or base model. So that is a very general purpose oriented model, so it can accomplish tasks across different domains. But after that, a lot of adaptation would happen to develop customized LLM models. That is actually where we see most applications. This downstream applications is the most popular, and this is what we are actually interacting with every day. So it's very important to understand the downstream of this whole picture, the model adaptation and the use of customized large language models. And these customized large language models can either be general purpose or focusing on specific domains. For example, we could develop customized large language models for a specific company, P&G, or for a specific industry, healthcare, right? We just use the large language models for medical conditions diagnosis, for example, right? Very specific area. So that is in the downstream application as well. So this is an overarching framework. Give you another example why customized large language models are important, because we see a lot of limitations for the base model, for the pre-trained model or foundation model. And this is a simple example. If I give this question to GPT, maybe an early version, 3.5 or 3, what is the purpose of the list C in the code below? And I want to have large language models to help me answer this question. So basically, this is questioning, answering task. However, if I throw this question to large language model, because and a lot of the training data is from the internet, it's from the website, it's very possible that this question is included in some exams in computer science or programming classes. And a lot of content on the website is after this question, it shows you this is a multiple choice question in the exams, and it shows up multiple times on the internet. And large language models pick up that context, and then the prediction of the next word would be the multiple choice A, B, C, D following the question, right? So that's based on the word prediction nature of large language model. If it just relies on the training data from the internet, it will give you this answer, which is not correct, which is not what you want. You want the large language model to answer the questions for you. So you need to improve the performance of the large language model. It's not perfect. So that's the reason we need to use a lot of techniques to explore the model adaptation. Some important adaptation techniques are prompt engineering, RAG, agentic systems, and supervised fine-tuning. And if I categorize these adaptation approaches, two directions you can go. You improve the model itself as one direction. The other direction is you improve yourself. You improve how you use the model. Falling into that category, we have prompt engineering, how you can give better prompts, give clearer instructions to the model. In RAG, retrieval augmented generation, is you provide external resources, external knowledge. You give additional learning materials for your model so it can customize the responses based on the materials you provide. So that will give you more accurate answers. So that is retrieval augmented generation, RAG. And a third approach is you can build up these agentic systems. You build up the agents, AI agents, and let the AI agents to work together, collaboratively achieve certain tasks. So those are some different approaches to improve how you use the model so that you could get better results. The second category, you improve the model itself. Just let the model do better. So you can achieve that purpose through supervised fine-tuning. You need to open up the black box of the large language models and adjust the parameters within the models, which is a very complex process. This framework also matches to our roadmap for this course. Next week, we will go into the first general approach, how to improve the way we use the model. We start with prompt engineering. In week 3, we will talk about RAG. Week 4 and 5, we will talk about AI agents and agentic systems, how to build the agentic workflow as a system. And hopefully week 6, we could talk a little bit about supervised fine-tuning. In the last week, we will talk about governance and the ethics of GenAI. So we'll also talk about the impact of generative AI on future of work. So that is the overall roadmap for this course. As a summary, we talked about generative AI basic concepts, how it was born, and what it can do in different applications across platforms and domains. We talked about some important topics around large language models. We just look at the text-generated models. How do they work? It is a text generation tool, and the mechanism is to predict the word one by one in sequence. How are they built? They are built through 3 stages of pre-training, fine-tuning, and human preference fine-tuning. How are they evaluated? We talk about a lot of the evaluation is around the accuracy of the output. But we also need to consider many other factors like the speed and the cost. And at last, we talk about it is very important for us to learn how to customize large language models through different approaches. That's what we will cover in the following weeks.